This video is about the development of Western astronomy and modern science. I focus on the rise of modern science in Europe, from the ancient Greeks to Isaac Newton. Although other civilizations were very interested and skilled in astronomy, the Greeks were the first ones to try to explain how the universe worked in a logical, systematic manner using models and observations. Modern astronomy and all of science has its roots in the Greek tradition.
In the lecture outline, the first vocabulary term is for the planet motions lecture. The second set of terms is for the ancient Greeks part of the history lecture, and the third set of terms is for the Renaissance Europe part of the history lecture. The planet motions lecture ended with a description of retrograde motion. Figuring out the correct reason for the retrograde motion required a major revolution in our understanding of our place in the universe, which I'll get to in this lecture.
Modern astronomy has its roots in ancient Greece because they invented astronomy when they put their observations together with their geometric models of the universe. Their belief that the universe is a rational place, following universal natural laws, and that we are able to figure out those laws, is a bedrock foundation of science today. There are entire books written and college courses taught about the history of science, so what I cover here is just a quick hop, skip, and jump through history with a focus on how we found out how the planets move in space. The fourth chapter of the Astronomy Notes textbook goes into a bit more detail.
The first person we come to in this quick overview is Pythagoras. He's the first one we know of who articulated some basic principles known as the Pythagorean paradigm. A paradigm is a general consensus of belief of how the world works. It is a mental framework we use to interpret what happens around us. It is what could be called common sense. The Pythagorean paradigm has three key points about the movement of celestial objects. Number one, the planets, sun, moon, and stars move in perfectly circular orbits. Heavenly objects should have heavenly divine motions. Number two, the speed of the planets, sun, moon, and stars in their circular orbits is perfectly uniform. Number three, the Earth is at the exact center of the motion of the celestial bodies. This is a geocentric universe. About a century after Pythagoras, we come to Aristotle, who had probably the most significant influence on many fields of studies, science, theology, philosophy, etc., of any single person in history. Aristotle developed a physics that required an Earth-centered universe and a theory of motion where the natural state of objects on Earth is at rest, and moving objects will move toward the Earth's center. Also, this physics assumed that the Earth was unique with its own set of physical laws that were different from how things worked in the heavens. The Earth was a world and filled with change and decay, while the planets, moon, and sun were perfect, unchanging, and essentially ornaments on the sky, not worlds that could be explored. For the motions of the planets, Aristotle used Eudoxus' model in which the planets and stars were on concentric crystalline spheres centered on the Earth. Each planet, the sun, and the moon were on their own sphere. The stars were placed on the largest sphere surrounding all of the rest. The spheres spun on the same axis that goes through the Earth, each at different speeds. But how could this explain retrograde motion? It didn't. A few centuries later, Ptolemy created a geocentric model that seemed to definitively explain retrograde motion using the best features of various geocentric models and the most accurate observations of his time. This model would last for about 1,500 years, which is why I have the word final in quotes. He added some refinements to explain the details of the observations. An eccentric for each planet that was the true center of its motion, not the Earth, and an equant about which each planet moved uniformly in relation to, not the Earth. But the key thing that explained retrograde motion is the epicycle. Each planet is on an epicycle, which is a small circular motion that is centered on a point that moves around the equant in a circular motion. So, circles upon circles. Ptolemy was successful in having people adopt his model because he gathered the best model pieces together, used the most accurate observations, and he published his work, ensuring that his ideas would last long after he died. One other important piece for his model lasting so long is that his model did work. It accurately predicted the planet positions. When you select the image, you'll bring up an animation of the epicycle action. The planet is the brown circle on the epicycle. The orange circle is where the planet appears to be as viewed from Earth. The planet appears to move backward when it is on the inside part of its epicycle. So that also explains why planets appear brighter when they are retrograding. They are closer to the Earth. As I said before, the model correctly predicted the positions and brightnesses of the planets. Ptolemy's model was incompatible with Aristotle's crystalline sphere model and the Pythagorean paradigm. A planet on an epicycle would crash into its crystalline sphere, and the motion is not truly centered on the Earth. So Ptolemy adopted an instrumentalist view. This strange model is only an accurate calculator to predict the planet motions, but the reality is Aristotle's model.